start doing confidence intervals. Confidence? Yeah. Why was that a weird word? So, in the examples we've done up until now, we've kind of started with this assumption that we know the population information, and then I take like one sample, and then I take a bunch of samples and average those all together, like the blue bars that fell down. So that's not how the real stats world works. The real stats world is you don't really know the population information. You take a sample, and from that sample, you try to, it's called inference, you try to infer something about the population. So like, quick example, raise your hand if you drive to school. 1, 2, 3, 4. Okay, so let's say it's 80% of you. So 80% of you drive to school. Would it be fair for me to say that 80% of the whole school drives to school? Would it be fair? So let's just say juniors and seniors. Screw it. Let's pretend they're juniors. Let's say, okay, would it be fair for me to say 80% of juniors and seniors drive to school? Would it be fair for me to say 80% plus or minus 10 each way drive to school? What I just did was make a confidence interval. So 80 would be like the middle. And then if I go 10% each way, that's called a margin of error. So we're going, okay, I think it's between 70 and 90. The true answer is somewhere between 70 and 90. So we take one small sample, and from that sample, we try to make like a guess about what's really happening in the bigger picture. Like our sample's not perfect, right? So there's going to be error. This is like when they do polls, that you see in the paper, like 51% of people said they vote for Donald Trump. Plus or minus 3%. So they took a sample, and they're like, okay, we're pretty sure that the true answer is somewhere between 48 and 54. So we're taking one tiny snapshot and trying to make an inference about the bigger picture. Does that make some sense what I'm going at there? Okay. So that's called a confidence interval. So there's 4 different kinds that we're going to go through. We're going to start with a one sample. So this is an inference template. We'll be using this for a couple months, basically. So there's confidence intervals and there's tests. We're going to spend a bunch of time on confidence intervals. We're going to spend a bunch of time on tests. And this sheet kind of applies to all of it. It's kind of like a walkthrough to kind of guide you through the steps you need to do it. It's almost like writing a paper. Like there's certain steps you have to put on here. But you don't get this template on the test. It'll just be a blank sheet paper. So just make sure you're studying. So this is called a one sample proportion. Z interval. So Z means norm. So let's look at number 1 on the sheet I gave you. So I take a random survey of 100 mild voters and find that 55% of them are Republicans. Construct and interpret a 95% confidence interval to estimate the true proportion. So I got 55 out of 100 people said they're Republicans. 95% confidence interval means I want to make my margin of error big enough that I'm 95% confident that the true mean is in there somewhere. So right now it's 55%. If I say it's 55% plus or minus 5, that would give me like 50% to 60%. This is good to write down. This is stuff we'll talk about over and over again, but it's a good starting spot. If I say it's 55% plus or minus 10, what would that be? 1 to 1? That's what you see what I'm talking about. Yeah, 45 to 65. Which one of these intervals, let's call that interval A and interval B, which one are you more confident captures the true answer in there somewhere? B, right? Because it's bigger. Like I have more margin of error. I have more room to make a mistake and still capture the true answer. Another way, yeah.
If
less confident in the work that I did, I'm more confident that my answer's in there somewhere. That's what people screw up. So it's not the confidence in your work. It's the confidence that you capture the true answer. You're right. Like, this is a huge margin of error. Like, I don't really feel very good about it. But that's why I give myself such large wiggle room. Like, if I told you to guess my weight, this is scary. Somebody guess give me a 20-pound interval that you think my weight is in. I'm not going to get that, I don't care. Give me a 40-pound one. Like, so you go 80 total. What? Well, let's make it like centered around the same thing, actually. So, what's the middle of this one? 200. So let's say we go then 160 to 240. Still not big. Let's say we go 140 to 260. Now we're big. So, which one of these do I have the most confidence contains my true weight? The last one. So the bigger your interval is, the more confident you are the true answer is in. I mean, I've seen that. Like, I've seen articles like this. 60% of people will vote for Bernie Sanders, plus or minus 20%. So what they're saying is somewhere between 40 and 80% of people will vote for him. Like, is that useful at all? No. But they're so unconfident in their work that they have to make their range like so large. I wouldn't bother it, but I've seen it. But they want the headline, right? They want to be like, alright, so that's what we're trying to do. So our first sentence is going to be very similar. So we're going to say, we want to estimate. It's like your thesis statement. The true proportion of Milan Republicans, let's say, at a 95% confidence level. So I want to be 95% sure that the true answer is somewhere in between these two numbers that I'm going to put up. So that's like your opening statement, your thesis statement. That's just like the start of your essay. So just think about this, like what we just talked about. If I said I wanted to be 100% confident, would my range of numbers be bigger or smaller than me saying 95%? It'd be big. If I want to be 100% confident, I'm going to say 0 to 100. I'm just going to be like, all right, screw it. I'm 100% confident it's somewhere between 0 and 100. As my confidence level goes down, I can start to narrow. So I might be like, okay, I'm 50% confident it's between like 52 and 53. Like, I'm not very confident, but I can give you a small interval. I'm just not very confident. And as you get more confident, your interval widens. Okay, next thing you do is check the conditions, and this is similar to what we were doing last chapter. I put them on the board up there too. So you got to show 3 things. One, is it random? So usually you're going to write like problem states. So problem states random survey. Or it might be like problem states SRS. Two is their independence. And independence is your N is less than 10% of the population. So that's going to be 100 is less than or equal to 10% of all Milan voters. Because that's the population I'm interested in, right? Is like the Milan voters. I think there's more than 1,000 Milan voters. So. And then the third thing for proportions, so these two are the same, because we're going to get into confidence intervals with means and confidence intervals with proportions. If it's proportions, it's the NP-NQ thing. If it's means, it's the n is greater than 30 or the population is wrong. So I need to show that NP is greater than or equal to 10 and NQ is greater than or equal to 10. I can't just like write that, I have to actually show it. So over here I'm going to go like NP equals, so I've got 100, what's P? What's P in this problem? 0.55. Like, I don't know the true P, right? That's what I'm trying to figure out. But I have a sample, and that's the best estimate I have for P. So P is 0.55. Are you typing 100 times 0.55 in your calculator? So, those three things, once they're true, I can carry on with the problem and do the rest of the work. But they will check you on multiple choice, especially like, are these true? Like, you saw the test, so like, are these conditions met? Which conditions are met? That type of thing. So I gotta show these three things: random, independence, and then this is like your sample size situation. It's like a general phrasing that the AP formula sheet uses that I want to make sure I use. I want to double check it before I Alright, so the confidence interval is always going to be the statistic plus or minus the critical value times the standard deviation of the statistic. So there's 4 different confidence intervals we're going to do, but this general formula applies to all of them, and this is on the formula sheet for the AP test. That's what I was checking, like I was using the same language they were. So in this case, we're dealing with a proportion. How do I represent a sample proportion? What symbol do I do for a sample proportion? PX. Plus or minus the critical value, you're not going to fully understand for today probably, but just roll with it for today. It's going to be called Z star. And then the standard deviation of the statistic. So what's the standard deviation of a sample proportion? It wasn't the board. I gave it to you for the test. I remember it. Square root of PQ over M. You gotta be faster if you want to be mine. Sorry, Ken. So now we're gonna fill in what we know. So in this problem, what's P hat? 0.55. Plus or minus. So Z star. You're gonna go to your calculator. Type in for this one. So what I'm going to do, like, just so you know what's coming, we're doing this problem like with the numbers and with the specific example. Then I'm going to back up and give you like a general template, and then we'll go back and do more of that. So there'll be like more instruction on the general template. But what you're going to type in here, you're going to go second distor, and then inverse norm. 1.95 divided by 2. And if you have those things that pop up, just leave them as they are, like the 0 and the 1. Dister is the bars. We can get you a new calculator. Okay. Hit enter, and that's your z-star. So 1.96 is your z-star. I understand you don't know what that means yet, but just trust me for now. Did you get 1.96? That's my main issue right now. 1.95 divided by 2. So the general idea is if it's a 98% confidence interval, you'll do 1.98 divided by 2. If it's a 90%, you'll do 1.90 divided by 2. So you're just putting the confidence interval like in that spot. We good? We got 1.96? Alright. Fill in this stuff. So P is 0.55, Q is 0.45, N is 100. So now you're going to go 0.55 plus or minus, and you got to do some math. I want you to figure out what all of this comes out to be. I'm terrified to see how Riley rounds. See how it goes. I got 0.0975. What? I got 0.0975. Yes. I was worried if you might have rounded on the way there, which would have put us at a different. Yes. Are you guys getting 0.0975? All right. So this is called your point estimate. This is called your margin of error. I know I'm kind of like overflowing the box here, but and then what that leads to, so what you're going to do is, start with 0.55 and subtract 0.0975. See what you get. So this is 0.4525. And then do 0.55 plus 0.0975. Let's see what you get. So 0.647. You with me on the numbers? Getting the same thing? It's not what I'm stuffing in? It's not what I'm cooking? Okay. So that's the math. That's actually your answer. I'm 95%. So what does this mean? I'm 95% sure that the true proportion of Milan Republicans is somewhere in between there. Like, that's not a great survey. That wasn't a very big. Yeah, let me ask you. Why is that so wide? Why is this not, why is it not narrow? Why do I have to make it so wide to have confidence in my answer? I didn't take a very large sample, right? So think through what would happen if I took a larger sample. If I put 1,000 here, what would happen to this part? I would divide by a bigger number, which makes the overall number smaller. So I would be adding or subtracting smaller numbers, which would narrow my window. Does that make sense? Okay. Alright, so then you gotta do your conclusion. Conclusion is, we are 95% confident that the true, and you're just circling back to this, true proportion of Milan Republicans, because that's what we're trying to find. So you gotta go back to your intro statement. 95% confident that the true proportion of Milan Republicans is between 0.4525 and 0.647. That's your process. You're going to do that process probably 100 times in the next month or so. I don't know, 100. That might be an exaggeration. 30, 40. Questions anywhere? I'm going to do a template, but like for right now, are there any questions I can help with there? So take, I should have told you to grab multiples of these. Come up and grab like 3 or 4 of those. Shut up, Meads. There's like 500 there, don't worry about it. They'd have to scream at Rodriguez first. I'm nowhere near Rodriguez.
Oh, so you got to give me a hard time for asking for one sheet of a transcript.
You're not a teacher.
I was checking you for this one.
She gave you, really?
Oh yeah, she's like, I'm not allowed to. I was like, really? She lying?
How are you supposed to get it printed if she can't? Because you can't like access it, can you?
And I was like,
Well, you have to order it.
yeah, but mine kept ordering it wrong.
Yeah.
I was like, hey, can you just print this from my wallet? It's like, I'm not allowed to do this.
She printed mine. She just said, I'll pay hers for you. Because
Okay.
Jim wasn't sure about everything.
So what I want to do now is make a template. So what you're going to have at the end, there's a 1 sample proportion, there's a 2 sample proportion. There's a 1 sample mean, there's a 2 sample mean. Those are all intervals. Those are all also tests. So that's 8 things right there. Then we get into chi-squared, which is 3 more things. So you're going to have at the end of all this 11 of these templates. This is basically the rest of the class. There's going to be 11 of these templates. So what some people do is keep, like, this is your guideline for this type of procedure. If you keep, like, all 11 of those in one spot, I think it makes it a lot easier to study and go back. I've seen people, like, laminate them and put them in a folder. I think that's a little excessive, but I didn't hate it, to be honest. So. But this is, like, your first template. There's 10 more coming. Okay. So when you get 1 sample proportions the interval. So first of all, how do you know how to use this method? They're going to ask you to estimate, and they're going to give you, I mean this seems obvious, but 1 sample proportion. So that's like your clue to use this method. Where if they give you 2 sample proportions, you'll do the 2 sample proportions. Give you 1 sample proportion, but ask you a yes/no question. That's not an estimate anymore. Then we get into tests. Okay, so you would say we want to estimate the true population proportion. I don't think I wrote the word population in my last example. You don't have to, but I think it's helpful because it really reminds you, like, okay, we're after information about the population of blah blah blah. So you put context in this spot at a blank percent confidence level. So, like in the last one, we put mild Republicans here. It could be students who drive to school, students like MCM. Please don't, like every year this happens. Someone will, like, I'll give the question on the test, let's say it's that mild Republicans we used to. Someone will literally write the word context on the test. Put the context in there, don't write the word context. And then this can change. This could be 90%, 95%, 98%, whatever. Conditions, so there's 3 of them. You got to show that there's randomness, and it can be stated or assumed. Like you can say if it's not in the problem, you could be like assume SRS, but usually it's stated. There needs to be independence. that's your n is less than 0.10 times big N. And then there needs to be the NP is greater than or equal to 10, and the NQ is greater than or equal to 10. You have to show that. You can't just like state it. You have to prove it. Same with this one. Just show that one too. Am I going too fast or we good? Am I good to keep going? Okay. And then you got your general formula, which is the statistic plus or minus the critical value times the standard deviation of the statistic. So when we're dealing with sample proportion, your statistic is pi. Your critical value is z star. Whenever we deal with proportions, it's always going to be z. And then the standard deviation of this one is pq over n. And these can change depending on what type of interval I'm doing, but like your general format is always the same. Then what you do is you put numbers in all of those spots. So you put a number there, plus or minus a number times, number times number. So basically you're writing the formula in words, and then in symbols, and then with numbers. So you're writing it 3 times essentially.
On the test, you could just skip to like the bottom.
You don't want full credit. You gotta show all this. Yeah. I've shortened it down as much as I possibly can. Like you should see some of the AP answers on these. It's like a 2-page essay. I've made it as condensed as I can make it, but you gotta show all the stuff I'm putting here. So your test in this chapter will be like 2 of these, and maybe like 10 multiple choice. And so you won't be doing like, here's 10 of them for a test. Yeah. Then you work out the math, and then you're gonna have like number plus or minus number. So you gotta do some math to get there. And then you're going to have your interval. One thing I should add is this z star, like how do you get this number? That's the only thing that's kind of unclear, I think, at this point, and that's the inverse norm of, if I say like 1.xx divided by 2, does that make sense? You do not have to write. I'm just showing you how to get that number. Does that make sense? 1.xx divided by 2. If it's 95%, you do 1.95 divided by 2. If it's 90%, you do 1.90 divided by 2. Is that a fair way to write it? 1% divided by 2. I don't know how you want to write it. And then at the end of all this, I'd actually want you to do this too. So then you're going to point at this and say point estimate. You're going to point at that and say margin of error. At the end of it, you're going to summarize and say we are blank % confident that the true population proportion of blah, 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 whatever the context is, between blank and blank. So what I'd like you to do is try number 2 on the sheet I just gave you. See if you can work through that process. Like, you got a template, you got an example. I'll work through it up here too so you can see it. I should note that this is probably the most often forgotten thing. If you don't label the name of the test on the AP test, you lose a point. So these are 4 points. Like a free response on the AP test is worth 4 points. If you don't label the name of the test, you're docked 1 immediately. So you're capped at like a 75% if you don't name it. So you have to title the test. It's especially easy to forget when it's a blank sheet of paper, not like a template. So what I usually recommend people do is use the template to start, but as you get more and more comfortable, start like using blank sheets of paper more often instead of the template. Notice that I didn't tell you P hat in this one. I gave you the information to find it, but I didn't tell you. So if 24 out of 40 participate in extracurricular, you can just do 24 divided by 40 to get the proportion. So sometimes instead of telling you the percent, they'll give you the numbers and you just divide it.
Question.
Yeah.
Independence. So like, since we're using 40, we're kind of just as
So 40 is less than 10% of all MHS students. There's more than 400 here, right? Or 40 is less than 0.1 times 700. I don't know how many people are here. 700. We had like almost 1,100 5 years ago. So you did inverse norm 1.9 divided by 2. Yeah, so 90% you do 1.90 divided by 2. 95 you do like 1.95 divided
I
by
did
2.
1 times 9.
That's that XX thing I was trying to say. Does that make sense?
Yeah.
Yeah, I'll put up like half at a time, otherwise it's too small to read. But there's your top half-ish. The order doesn't matter. Like, I screwed up the order, so it doesn't really make logical sense that I put the numbers in before the symbols, but it's okay. It's just not how I would have liked to teach it. So I just put the arrow there. That's messed up. Like, it's not wrong, it's just not the order I would have preferred to explain it. Bring it up, let me know. If you're getting different numbers, you're not sure of wording, or what else. No, you don't have to. Just do it in your calculator and then you show it. I was doing it on the template, so it should be fine. You don't have to write the inverse norm. I just wrote it on the template so you can like know how to find that number. Any questions? Can I scroll down past this? Like, can I move this part above my hand off the board? You good on that? Okay. You can see the rest of it. So everything in there matters. Like, you gotta make sure you put everything I put. Your numbers match. You have the conclusion that says what I'm saying. It's like a very strict guideline for how to write, like a stats essay. And I've stripped away all the stuff you don't need to put, so you gotta put pretty much everything I have. Inverse one 1.90 divided by 2. And the 90 is 8%. Yeah, the excess thing.
That's the one writing when I've actually done it in English with this.
This is what?
This is more writing when I've actually done it in English.
So again, that number is coming from inverse norm of 1.90 divided by 2. That's 90 because it's a 90% confidence interval. I have one question I want to ask you when I win. Just up here a second. between these two numbers? It would be smaller. Good. This would be smaller. You'd be adding or subtracting smaller numbers to 0.6, so it would be compressed. Second question, if I wanted to be more confident that I contain the true answer in there somewhere, let's say I want to be 95% confident, what happens to the distance between those? They get big. Like if I want to be 100% confident, what do I have to say? I have to say 0 to 100. Yeah. Questions about anything?